is you'll see here kind of what we're seeing on the screen now. You'll see this, we call it a pepper pot effect. If you ever look at the top of the pepper pots, lots of little dots, and that's what we call pepper potting. In a system that's got a good data set in it, they are good cells, and here is areas where you have lack of dominance. And you can start to investigate using other analysis into those particular areas, if that's your area of concern. Do all of you here in the room look at RF analysis? Is that your role, or do you do subscriber, device? What's your expertise? Hands up for RF. RF, anyone? Radio frequency? What about the other guys? Subscriber or any specific analysis? No? So which areas of expertise? Sir?
I'm looking at subscriber
Into subscriber, yeah. Subscribing that. Yeah, okay. So this may not be the kind of analysis that you're interested in, but from an RF perspective, this is very much an area where the optimizer can use geo to start to analyze areas of poor coverage. So let's just imagine for 1 second that the area here in the south is subject to poor coverage. What we can do is we can use our raster tool. Okay. So if we look at the main screen here that I'm touching here, so I hover it over that, you see it's raster analysis of point. Okay. So what I'm going to do is I'm going to select that tool, and then I'm going to select an area down in the south here, there. Okay. And that's telling me at this moment in time, off that basis, this analysis I've got, that's the best server, and that's the traffic volume that I've received. So you can see the cell here. Okay. Let me just take this 1 second. What I'm going to do is I'm going to copy that cell. So I've selected it. I'm going to right click that cell. If my computer catches up with me. Okay. And I'm going to copy that selected value. Okay. I'll just close that. And then if I right click the map, I select point again, right click the map. I think, excuse me, the lag in my system is affecting me a little bit. So if I right click the map here, okay, I can search for sites and cells from this location. So I select that, and it brings me up a network search box. When it eventually catches up. All right, okay, so here's my network search. So you can see here in the tabs, select the OTS. Okay, so this effectively looks into my site database and brings me up my cells. So what I'm going to do is search for that cell and put it in here. And it gives me the option to search in. In this case, I'm going to use label. That's the most often search. We report the cell label in the tool, okay? But you can see here I can search from a whole other set of attributes from that. So I can find myself Nokia sites or particular RNCs. It's just a way of finding your way around the network if you need to go directly to a point. In this case, I'm going to use label. So the value I copied earlier should still be here. Okay. So that's brought it in, and it's telling me here, if you look at the tool brought up, that I'm 1.4 kilometers from it. That's my label, that's my RNC, and various other attributes of that particular cell. In this case, I'm looking at a specific frequency. So if I select this, and you can see the bottom three tabs, not tabs, but controls are highlighted, controls. Bring it to view, highlight, and correlate. We can ignore correlate, okay? That's not part of your system. So all we'll see is bring to view, highlighted map. And I'm going to highlight it in the map because that's always a good idea. I'm going to bring it into view. Behind the scenes, that's moved the map so that the cell of interest, in this case, is brought into view. And I've got a little bit of, so there you go. You can see it better now. So that particular cell that I was looking at, where I identified that was best cell in that particular bin, you can see it's now highlighted here. So there's a couple of other things we can do from there. We're kind of looking at dominance, and we looked at call table analysis. So what I'm going to do here is I'm going to look at the RSCP, the average power transmitted from that. And you can see there's my average powers again in my bin. And I can take my raster control here, and I can look at the, here we go, the values that we've got in there. So we can look for, visually see poor areas of coverage for power. And we can also look at our interference levels as well, if we're optimizing the cell. Now, we talked about dominance earlier and best cell. And like I say, here now, if I was picking an area of poor dominance, then I could look into this RF analysis here, okay, and I could identify the areas I've got of poor dominance of that cell, or in this case, interference, which is likely the cause of poor dominance. Could be power, cell footprint, of course. So that's the kind of area I'm looking at there. What we can do to investigate that further, so we've gone for best server. Let me just disconnect this here. I'll put my best server in here. And my cell is here, okay. Analysis. So from this, we could identify what I would normally expect is that solid area, and then we could identify areas of pepper pot where a cell is perhaps causing interference. So we looked at poor coverage areas in 2.3. The other thing we can look at also is pilot pollution in this particular area, which is the pilot pollution NDB. So if I drag pilot pollution on, this is going to give us some other parameters. So again, I'll use the frequency that I've already set because that's already in the map. So I'll select that particular frequency. And what I'm saying to this is, show me the pilot pollution in this area. And we can set specific parameters for that to be the case. So I'll just cut off the others. Just to make sure all the other analysis is closed down so we can see this. So what Geo is showing me now is the 50-meter bin value where, if I look at the P here, so that's the threshold in dBs. In this case, it's 3. You can modify that threshold if you need to. This is showing me the areas now where I have power pollution in dB in the number of times that's being seen, or that particular threshold is being passed. So you can see here, according to this here, that I've got a little bit of pilot pollution in this area here, around about this point. What else can we do from this? We can make a selected area and look at cell footprints. Let's see. Yeah, sorry, just to quickly go on with the pilot pollution here, you can see here where that value in the bin is with the polluter is greater than the best server minus n. So that's the threshold of 3 dB that you set there, okay? So by clicking on P, if you need to change that threshold, you can. If my system catches up, there you go. So whatever threshold you want it to be considering it's interfering, you can set in that particular value there in P, okay? So that would indicate an area here where we have potential pilot pollution in this particular area. Further to that, we can also look at top polluters in here, and I've got to just check on this one. So ordinarily what we would do here is, so we're interested in this particular area here. So I'm going to just select polygon around that, okay? And then I'm going to pull into here my pilot pollution top polluters. Okay. Sorry, my apologies. That's a table. I should have not noticed that from this graph here. Okay. So what I can do is pull that in here. Again, I need to kill this because what I need to do is to select the area of interest, which is my polygon. 1 second, where's that? There's my polygon. So what I'll do here, actually, I'll just show you another way of updating the filter. If I click that and drag it across, if I hover it over the filter, okay, and release it, you'll see that it's updated that filter already. And it's called that filter number 4. It just happens that there are other filters in use. But that is a good way of copying any particular item from the menu. The other thing you can do is this bottom in the corner. Say, for example, I didn't want to create a polygon here, then I was happy with this square here, and I wanted to just analyze this. I can actually drag that little square icon there into the filter, and that sets the geographical bounds for the visual area of the canvas. So that's another way of setting the area. So what I've done here is I will then run that analysis, and that's looking for the area under test, and it's telling me here that that my top rank polluter here is this particular cell here. Okay, so if I copy this cell value, sorry, this has been quite slow. Just copy it, Control C, see if I can do it that way. Right click my map. Remember the search function. I think that was the top polluter anyway, wasn't it? Okay. Again, we can bring to view and highlight in the map. Okay, so that particular cell that I've just brought into view there, and it should be highlighted. If I can see it, just disconnect this. Okay, so that cell there is actually my top polluter in that cell. Okay, so we can start to, if from an RF optimization perspective, we can start to look at why that might be the case. I'm just going to deselect the polygon now, so just we can see the map properly. So one of the other things I can now do with this particular cell, having identified it, is I can right-click that cell. If it'll allow me to do that. Just select the tool. All right, so it almost let me do it. So let's try again. If I right click that cell, right, there's a significant lag here from my system. All right, so once I've hovered over it with my select tool, remember to take the select tool first. This will allow me now to analyze the footprint of that particular cell. So I'm going to look at the RF footprint KPIs on this, just to see what's happening. And what's going to happen here is this will go off, and this will now run a footprint analysis on that cell that we've identified as a potential polluter in this system. Okay. So let's have a look here. Okay, that completed it. Just force it again. Okay. So as you can see, my my system at the moment is lagging a little bit and not giving me the interaction that I need. So I'm connected via VPN back into the USA, so it's a little bit slow. So what I'm expecting to see from this is a cell footprint, and I can't see that at the moment. If I click that server on there, let's see. Let's see where all my data's gone. Okay, my data appears to have gone missing here. I'm sure it's something to do with me dragging the cursor around. It's even the best cell data has gone missing. Yeah, significantly lagging here. I'm going to just change my VPN to see if I can get a quicker connection to the system. You can still see me? So I'll just log on again to the system. Yeah, that's what's happened there. So whilst I was sweeping around the screen and sticky, warm fingers, I'm not used to the humidity, I think. So basically what I've done is I've deselected the analysis results. So that's fine. I can untick the ones I'm not interested in. And let's have a look again at that, the footprint of that cell. Okay, so that's the, what I really want to know is the power of that cell, right? So that's the footprint of that particular cell. And if we then look at the areas of pilot pollution here, so we can see where that overlaps. Okay, so we can see here, this is the area of pilot pollution we're interested in, around here. See? And when I map in the RSRP over that, you can see that particular cell footprint is radiating into that area. So you may want, so I don't particularly notice this area, but you may want at that point to consider whether or not that's a useful cell to transmitting that area, whether or not it's overshooting, and what you might want to do to reduce that in terms of maybe tilt, or you could consider any other optimization such as power. We have a particular way of doing this. We can actually look at, if I look at the RF simulation, 1 second. So footprints, statistics, propagation delay, optimization, cross-feed, performance. Okay, we'll come on to that in a second. I was just looking for an extra analysis there that I was going to use. But we've done the footprint diagnostics here. We're looking at the cell footprint analysis. Oh, so the other option is on 2.3.1. we can actually look at the footprints. Okay, if I look on the left here, I'll just close the call table down. Okay, so you'll notice there are a number of ways of obtaining the footprint. I actually clicked on cell to drive the footprint analysis, or you could actually use here specific analysis from here to go straight to. So there's two ways of initiating the cell footprint in Geo. Okay, it's a footprint. Diagnostics, we covered that. S server. All right. So yeah, we covered that in particular ECI naught as well. So if we looked at the footprint of that particular cell, which is polluting, we believe, if we run over that, you can see that also in that particular area, it's serving an area where its own interference performance is quite poor. So that within this data set, that is to me looking like very much a candidate of doing something about anybody being served by this cell isn't receiving a good experience, and the people who aren't being served by that cell are also receiving a bad experience. So that may well be a candidate for a down tilt. Okay, let's have a look further on. Strongest server. So we can look at that which is in the strongest server cell. Just close this down. Okay, I'm suspecting here that the strongest server has been deprecated because I don't seem to have it. We've got a later version of Geo on here that this is version 14 that's just gone on and been released on the system. Okay, so it may well be that in this instance at UMTS that may well have been deprecated. Propagation delay statistics. Yeah, so okay, that analysis may well have been deprecated. So what can we do on this particular cell? Let's just zoom out a little bit and we can have another look at this. So that's our cell coverage. We might want to improve the dominance of that particular cell to see what's happening there and reduce the overshoot of it. So if we go back into optimization, okay, then we can go into turn the tuning. Okay. Okay, so this is the analysis I was looking for earlier. Again, this doesn't appear to be present here. So what I'm going to have to do is to defer this. We can have a look at LTE, if that's okay. Let's have a look. The guys remotely getting me okay? The guys remotely can hear me okay, yeah? The remote people are good, yeah? Yeah, okay. So what I'm expecting in the optimization folder, and I'm not getting it, and I don't know why, so I need to have a chat with the guys back in the office. But if I go to the LTE function here, that's not available either. All right, antenna tuning. Yeah, so what I'm expecting in there was antenna tuning. So I'll just show you that basically in LTE to try and look at how we might do something on that. So I apologize that that's not in the folder for UMTS, but it certainly is for LTE. Perhaps it's worthwhile coming to this later, but I'll just give you an overview of what we'll be able to do. So by looking at this, we're going to be able to change some of these functions in here, and the data that's contained within Geo will then do a recalculation based on the parameters that you've changed here. So for example, like I say, I will go through it on LTE because it's definitely present. So with this cell here, we'll say, okay, let's let's change the tilt. Let's change that slightly. So what we'll do is we'll run that analysis. We'll enter the tilt value that we want to simulate. We'll put that in, and then Geo will calculate the new footprint based on the current RF conditions that it's got, and the fact within the parameters we know the existing tilt of the cell. Okay, so we know also its azimuth, and we know its power, and Geo will then calculate that footprint. So you can simulate the tilt that you would need there. Now we do have, this is the sales pitch, ever so slightly. I know that you have a certain scope, but we also have an automated way of doing this. So in some of the larger customers, basically what we do is we allow our own processes to automate this in the background, and you can actually set a much wider area and come up with a new tilt and powers plan. But that's something for the future. This is not included in this instance. But this is the way to do it. So there is a manual way of doing this if you find a cell of interest and you want to simulate the changes. Okay.
Just one question you asked me.
Yeah, I was just making sure that the guys were okay. The remote people okay. Got the guys remotely.
The remote from
No, they got the guys on the session.
section
Yes, the guys who were remote.
on my
Yeah. Okay. So that's kind of RF. Is there anything else that you'd like to understand about RF? Any questions that you might have on how this is implemented? Any thoughts? All logical? Yeah. Okay. Okay. There are some other functions that you can take out of the cells here for statistical distribution. So this is something that quite often we use for when optimization has been run, or we want to compare two cells, and we're looking at the cumulative distribution function in Geo. We can look at the statistics folder. Let's close that one down a second. And you can see that actually within that RF folder, there's a whole host of other functions that you might consider. This one here is interesting. Best cell by MOU. This is before I go into statistics. Basically, what we're doing, where previously we looked at the best cell by power, what we can also look at is the footprint of MOU as well. So you can see where that cell is serving the MOU. This is specifically very useful in LTE because LTE doesn't have the same richness of measurement reports that happens in UMTS. In UMTS, you've got the active set, so you've got a lot of things going on. In LTE reporting, measurement reporting, is such that actually you can, if a cell is not moving, if a user is not moving, or a device is not moving, then you're not generating a lot of measurement reports. So when you run the best cell plot, you don't get a contiguous area. Even when you've got good data in there for a number of days, you can look at it. So what you can actually do at that point is run the MOU, because the MOU is then on that particular one, on the server, based on that server, and then you will start to get contiguous plot. So best cell by MOU is very useful, but UMTS maybe not so much. Okay, so statistics we're looking at. So there's a number of RF histograms that we can produce here. Just close this one down. My polluters, get rid of that. So we can look at the RF histograms in here. So let's have a look at a cell, shall we? So I've still got that cell here. Oh, sorry, my apologies. That's something else you have to be careful of as well. You're running the analysis in the wrong folder. Okay, statistics. Close this one down. Let's have a look at the RF histograms. Okay, So this is effectively telling you, I could run that on a chart really. I think that's probably a better way of doing it. I'll just close that down, pop this one on a chart. Okay, so this gives you the particular values here for that cell, the distribution of that, okay? So this is the ECI naught histogram on that. So basically that's telling you here the number of samples within that, values you've got within that cell. Okay? So you can see roughly where the subscribers are receiving their best coverage. Interestingly, when you simulated optimization or when you changed the tilt, if you wanted to, the whole point of this interference curve is to improve it, but this one's actually not too bad. So say for if it was a little bit further this way, then obviously what you want to do by tilting is you want to push it this way, because these here are the values of ECI naught that this is receiving. Yeah. Okay. So you can see here, this down here would be poor, and this here served by that cell is generally good. Okay. But if it was this way, you might want to consider improving the ECI naught. This is typical of the histograms that you can look at. Let's look at RSCDF. In fact, that's cumulative. My apologies, I should have put the filter in here. Let's have a look at that that cell that we were looking at. So let's have a look at that particular cell. So that's the statistics for the whole area, actually. So you would say for that whole area that I was looking at, it didn't look too bad. But let's see what it's looking at, what it's looking like if I take that particular cell. Which, if I remember correctly, was this one here. Okay. Bear with me, I'm just extracting that cell identity from here. Okay, so you see here, this is the value for that particular cell. So you can see here, as we looked at on the map, we are serving some subscribers here in a particular poor performance area. Generally speaking, let me look, sorry, that's not very clear. So I can make that bigger. Yeah, hopefully that's slightly better. Yeah, so you can see here, once we get beyond this area here, then we're looking at certain subscribers that have been interfered with or not receiving particularly good service. People out here, especially that could be the ownership that we're looking at earlier. So if you tilted that round again, then hopefully you can start to remove those outlying subscribers that are being served. I've come across various instances where serving people a long way away is desirable due to overwater or something like that. But we know full well from this area, we've just looked at it, it's not overwater, so we shouldn't really be serving these people out here with that. That's an undesirable state for that cell to be serving, and it's causing interference. And if you compare that to the histogram we got for the whole area, you can clearly see that that cell itself is not giving a good service. Okay. Let me have a look at the couple of other histograms here that we can look at. So if we look at the RFCDF, cumulative distribution function, let me just do that in a table, in a chart, it's easier. Okay. RFCDF. So this is the particular function for that cell. So what we can see here is that how that is being served here. So okay, this is our RSCP. Sure, that is RSCP. 1 second. Yeah. Again, we've got the cumulative. I'm just going to add that cell to it. Run. Okay, that's one cell in it. That's not what I'm expecting. Yeah, okay. So this is the reported values of ECNO. So what I'll try and do is look at another cell in here, and I don't know if this is a better performing cell or not. But what I'll do is I'll select this cell here and add that so we can just compare the ECNO of the two here. So let me have a look at the cell I've got. So it's 2991. So what I want to see here is another, okay. So this is another cell here. So what I'll do is extract this cell. Same frequency. And using the edit function and the add filter, I'm going to add the new cell. I just happen to have picked the same cell. 1 second. Let me go back to this. It's not updated, that's all. Try again. Okay, that is a different one. Okay. So this is now going to compare two cells on the same graph. Okay. Just force that calculation of the analysis. Remember, I updated the filter there. That's not giving me a different, unless those are specifically overlaid. Let me have a look at that. Yeah, so one of the issues I have here is, of course, that I hadn't identified two differing cells, so it may well be that was overlaid. So let me just apply this and run again, see what happens. Yeah, so there's not a lot of difference between those particular cells there in terms of the ECI naught that they're looking at. However, that is a way of comparing two cells, even if I can't find one that. Let me give it one more try. I think that's important to try a different one. Hopefully I've got different values on this one now. Okay. Okay, that's definitely summing up the two by the looks of it. There seems to be a difference there. Let me have a look at this. So that is not giving me the result that I expected. Let me have a look at the edit parameters function. Yep, okay. So let's have a look at the various parts of the histogram. Let's look at RSCP. Okay, so my apologies. I think I know what's happening here. Schoolboy error from my point of view. I apologize. So I'm going to remove this one. Okay, apply and run. And okay. Okay, so what we have actually got two values here that's significantly different. So this cell here is one we were looking at earlier, and this one here is the one I just added there. So we can see that there are a number of different values on that particular cell. So if you were wanting to compare the two cells' performance in that particular area, you can't see this. There's an awful lot of information in here. I'm just trying to get to the bottom of. So that is now I know why. I'm looking at two different values. So you've got to make sure that when you do this, they were looking at the same thing. So here I am, the parameters. So what I'm going to do is look at the RSCP on this one. There we go. Okay. All right, so there you go. That'll give me the better RSCP, reported RSCP for that cell. Now, again, it's quite there's a lot of values in there, unfortunately. So this is my cumulative function, but you can see here that I have a significantly better distribution for this cell in red here. It's giving me a much more stronger values down there. That one is more dense within that curve. Is that right or wrong? I don't know. If you were an optimizer looking at this region, you would probably have a better idea of what population that's serving, and then you would make that determination as to whether or not that curve, which one of these curves is correct for the target area that you're trying to serve with that cell. Distribution. We should also have a look at the ECNO on there as well, just before we go. Okay, so there you can see a slight distribution where the red one is there's not a lot in that, is there really? I mean, you can see here that the grey cell is serving some UVs slightly better in terms of interference. Is there a trade-off between the mid-range and certain better here, where this guy here has had a better balance curve on the red? That's really left for you to decide as an optimizer what's a good curve and bad curve here. I would suggest that neither of these cells are particularly bad. So that's an example of how you can compare two cells in the area, good and bad. Okay, RF histograms, we kind of covered that. Yeah, and the default thing there was the bit I failed to pick up on at the beginning. The default value is the ECI naught. Okay. There's also RF overview, which is, this really is about looking at the distribution of your RF and values. I guess this is potentially quite an interesting, put a chart in, quite an interesting analysis. Let me pull up the links. So this is going to run on all my cells. So you can see here, this is the 50th percentile. And what it's doing is it's showing me cells that are RF-wise, RF thresholds above and below that. So you can see here there's a couple of cells in the middle that are, well, the RF values are slightly lower. But that gives me a distribution of almost all the cells in my area. You can define that, but also by a polygon to actually reduce the number of cells. And let's do that. We had a polygon earlier. Let's define that polygon and see what difference that makes. So we were effectively at this point going to analyze the cells within that polygon. So again, I'm just going to drag it in. Let me put these side by side on the screen. This touchpad is a little bit too sensitive, that's why I'm having the issues. So again, I'm going to drag that in there. You'll see that the filter's been updated. Remember that green with the star in it? It means I've changed the filter in it. So I'm now going to run that analysis. We should now see the differing RF performance of that group of cells within the polygon. So you can see here where which particular cells are being serviced. Does this one show it? No by standard. Let me check. Yeah, it is. So you can see here at the 50th percentile which are being served, the distribution of the ECI naught across those cells. Okay, and you can see particularly these two cells here. These two candidate cells for investigation, you can see that they're actually well below the rest of the graph. So if I actually hover over that, that should give me a cell value. Yeah, okay. So that's telling me which cell that is. So again, perhaps this is another good analysis for an RF guy to go to if you have an area of concern and select the cells that you need the poorest performing interference. Okay. And then you could do the footprint analysis on those cells, so you could reverse this. This might be a way in, not just best cell analysis, but perhaps you could do this in your target area. Let's have a look. There is also just close that one down. RF KPIs at percentiles. So again, this is similar to the RF KPIs, but this is going to show me where my cells are slightly better. So this is the percentile value. So if it's better than the particular percentile, then it'll show those cells. In this case, my analysis has gone. Sorry. Yeah, see, I've done that again. It's my fault. Okay. And it allows me to show the values that are better than that particular percentile that I've selected. I haven't got this filtered by any particular area. Yeah. So this is suggesting to me that I've got nothing better than that. I don't believe that. Okay. All right, so let's just look at the RSCP here. So again here, this is my values, if appropriate. So that's my RSCP values. So effectively, that's showing the RSCP values. Why that's not showing better than, I don't know. Let me have those values. Percentile value, TXP. Okay, I don't know why that's not giving me an EC I0 value. But there's other things we can look at there in terms of UETX power, and that's the recorded transmit power that the UEs are using. So you can see here, if I hover over that, where the UE power is raised. Okay, exactly which threshold that is working at, I'm not so sure. So I'll just check up on that, and if necessary, provide you some better information. That's not giving me the results I expected, so I need to just check on that. But basically, that's what we're looking at. We're a threshold, where a KPI is better than a specific threshold. That's where we should get an output. Okay. Now, interestingly, yeah, RF percentile. Okay, now I understand it. My apologies. I ran the wrong analysis. That wasn't my bad. Yeah, there you go. That's better. Okay, so this is showing you here where I've got a better value. My apologies for that. I ran the wrong analysis. So if I look at the particular example here, so I'm showing values where the ECI noise poor, i.e. it's over -14. And again, it will give me the thresholds there for RSCP and UETX power. So you can change those thresholds if you want to look at that area. I can look at the RSCP here and determine whether that's bad or not. Interestingly, in this particular view, I'm just looking at the power, you can see also where geolocation is giving me the road usage as well. Which result probably with highways under here or possibly train track. Yeah, you can see that the mobility function is starting to come into play, and the users can be identified as traffic. We'll come on to mobility in indoor and outdoor when we get into LTE. Okay, so apart from me running the wrong analysis there, and I apologise on that, any questions on the RF analysis in Geo? I think the concepts are quite straightforward, aren't they? We have, just to reiterate, we have the 50-meter bin, and the RSCP or the ECI values within that bin are averaged, and that's the view that you're looking at. It's quite a powerful view in a network. I don't know how you've been doing that previously, but that's quite powerful. Okay, should we take a brief break at this point? Is that suitable? We've been running for about an hour, haven't we? Quick 5 or 10 minute break, is that okay? Yeah. Okay, short break now for 10 minutes. Okay, we'll be resuming in a few seconds. Thank you. Okay, we're all here, ready to go? Hi guys, welcome back. When we get to the end of today, we'll have another session and get towards the end. And the offer that I just made still stands. At the end of this, as well as a question and answers, if you want to get on here and just play with the user interface, just run a few analysis, then please come to me at the end of the session, and I can guide you through a couple of hands-on if you want to run the analysis. Okay. It just makes up for you not having access right now, but it gives you the chance to just test the GUI and see what it feels like. Now, interestingly, in the next section, which is 2.6 Network Performance Score, this appears also to have been deprecated in version 14. Okay? I.e., deprecated means removed. So what I'll do is I'll check with the guys tonight, because this is fresh training material that's printed for me. Okay, so I have to say it's been a while since I looked at the network performance score in UMTS, and it's not there. So I can only assume at this point that it's been deprecated because the correct licenses are on the system. So we'll skip network performance score, and what I will do is I will look at some other analysis that is available to us on UMTS, and we'll look at IRAT. And IRAT is quite an interesting feature, right? Because assuming all your network coverage is good, right? Generally speaking, the user will be happy. Chances are, at some point, he's going to wander into an area where he needs to go somewhere else. Okay? So, an important feature of this is being able to look at the IRAT performance of your system. So, first and foremost, what I'm going to do is I'm going to show you an example of setting the geographic area. So, I know, for example, that all my data is in this town in Belgium. Okay, so I don't need to run an analysis, or every time I run a map. I might want to look at the whole of Belgium, but right now I'm only really interested in focusing my analysis here. So this is what I was saying earlier. So if I look down to the bottom right-hand side, you see the square. I'm going to take that, and I'm going to drag it up into the UMTS tab and release it. And I'm going to merge that, not replace it. I'm just going to merge it. And that will now take my geographical area and store it in that filter up here. So any analysis I now run will be on that area, okay? I have actually set the RNC. I could take the RNC away now if there were multiple RNCs, but I'm just going to look into the area. So any analysis I now run for UMTS will purely run in that geographical area. So there's a couple of things we can do here. You can see we've got some tables. So if I drag the IRAT performance by cell over, so this is going to run on my geographical area. And this will now, because it's tabular, will give me a number of cells. So here we are, there's my labels, and this tells me about my attempts and failures. So what I'm actually going to do is I'm going to right click the failures, and I'm going to go largest to smallest so we can filter on column. So we can see there that we have that IRAT success rate of 78.5% for that cell. If you wanted now to look at any aspects of that cell or drill down into the users on that, you could use that cell here, and then you could look at particular connection statistics. So looking here, calls. So we could at that point we could take that cell and look at individual call segments, which will come on tomorrow. Okay, so the individual call segments is a powerful way to getting to the user experience. So we'll come on to that one tomorrow. I think we'll finish the RF. So that's an example now of how you can identify your cell IRAT. performance. You can also visualize that, as you might expect. We can do that on a map. Okay, so let's have a look here. We can look at the map. So this is the map icon here, and it also tells us, by the way, if we hover over it, that it's a raster and it requires a map. So I'm going to drag that on, and I'm just going to let that run. I'm not going to filter it by any particular frequency. So you can see here now, if I expand that slightly, let me just create a bit more room on the desktop. Okay, let me just close this one down. Right, so we can see here where we've got lots of areas. So we can start to look at areas now where we've got high levels of IRAT attempts. You can see they're in red here. If I zoom in, from an RF perspective, I might want to look at other factors, perhaps drill down into the subscriber and see what their experience was using the connection statistics, which we'll look at later. So that's my attempts. I'm interested in my IRAT failure rate, if I can identify somewhere. Okay. So there's no massive one area. I think there are clusters of areas where IRAT failures are occurring. They generally appear to be roughly the same rate, but you can see here that there are clusters. Just zoom that out to see if there's anywhere else. And no, they're generally low levels. I think that's probably because we've got relatively low data. But you can see here that there are clusters of IRAT failures around this particular set of cells here. So you might want to look at the conditions as to why those IRAT failures are occurring. That's the rate in percent. And we can also do a count. Okay, so you can see here that, yeah, generally speaking, 10 to 20%. If I look at the raster analysis again, so I can click on that, and it tells me the values under that for IRAT failures. Okay, they're all much of a muchness, and I say that's probably due to the data rate. What I would expect here, if I got more data, a day or two's worth of data, that would start to see red blotches here, because they are areas of concern to me where IRAT failures are occurring. Even in that limited data set, you can see there that we're getting clusters of that. So once you can identify deeper into that, you can then look at the reasons behind that. Do a cold drill down, have a look at the three messages. So let's select, for example, a polygon there, and then you can look at connections within that, which is actually the user information. So that connections will then come up with the radio parameters, the RF information at the time, and you can right-click that connection, drill down, and look at the three messages. So that we'll come on to that tomorrow. Also, I mean, the attempts is quite good too, because clearly, you know, IRAT attempts are they're not unadvisable, they're important, but you can see here that these are the areas that are suffering, and you might want to look at this again. The hotspots are showing, the tallying. So you can see here that the peaks of my IRAT attempts are in these two little clusters here, a little cluster over this way. So the alarm bells are ringing. Why am I customers having to IRAT at that particular point? Okay. So what else is available here? We can look at drop diagnostics. Let's have a look at this. We could have a look at neighbor performance per, yeah, okay. So we could also look at the neighbor performance here of a particular area. So here we go. So this is handover performance within the target area of interest. So you can see here the particular handover type that's carried out and the relative success rate. If I go smallest to largest, okay. Generally speaking, the handover success rate is good. There's a couple of IRATs here that are giving me 0%. Handover attempt, smallest, largest to smallest. Yeah. So you can evaluate your handover performance. Again, on a richer data set, you would probably get more information out of this. But as an RF optimizer, it's ideal way of drilling down into your network and finding out what's going on. I think it's probably a good time, because I'm talking here a lot about KPIs and counters. I think it's worthwhile just mentioning one thing. what you will have seen thus far, if I drag performance KPIs across, okay, oops, apologies. Performance KPI is of course a map. I need a table. Let's have a look at cells. Cool summary. I'm just trying to find an example analysis that proves that allows me to discuss cell KPIs. Okay, this is on a table. So cell KPIs is running here. You can see, by the way, when I drag that across, you can see the examples I'm going to get at the top here. Now, this is a particularly good time to bring this topic up. So what you're going to see here is logically the KPIs per cell. The cells are listed on the left-hand side, and these are the KPIs associated with that cell. So let's have a look at the RRC attempts here. Okay, so I'm going to just sort that by high to low to have a look at the busiest cells within that particular area. RRC attempts. Do you remember when I showed you that diagram right at the beginning of how we get this cold trace data? You will have seen at no point did I mention anything about PM counters. And that's because PM counters don't exist in Geo. Now I know that most optimizers, they look at their OSS, they get their PM counters, and they look at the attempts, drops, and blocks from the PM counters. What I'm going to tell you today is that we also count the drops and blocks, but we do not have access to the same PM counters that the RAM does. The only way we can establish that is looking at the call flow between the radio and the call. And by looking at those messages, what we're looking for is we're looking for a cause code as to why that segment ends. And there are three possible ends to that segment. So call segment is when a user starts a call. And then at some point, an event happens. It could be a measurement report, it could be a RAB change or something along those lines, depending on the technologies, or an active setup date or whatever. So at that point, information regarding the cells is sent in that call trace back into Geo. And that's how we break a call up. So to you, the user, when I make a call, I start a call, I do something in between, and hopefully I manage to end the call successfully. To me, that's a successful call. In Geo, that will say a call initiation, and then it will say that the call setup is successful, and then it will go into measuring. Okay, that's put into the call trace data, and I'll move, I'll change the cell, that's an update into the call trace data, and I'll carry on. I might get GOTS, or I might get an IRAT, or the handover. All these events are in that call, and that breaks the call to Geo into segments. Okay? And that's how we analyze the call. Now, call segments are very important because they contribute to the size of the data that's being held in the database. So when a call starts, we say that's call segment 0. Okay? And if I'm moving along and I get all these things, they go, and those segments build up. If there's a long gap between the cells, then we initiate a new call segment. If I get handovers in rapid succession, Geo says, I'm not going to create call segments, I'm going to merge those call segments. And then that goes to the database. So all these call segments increase the amount of data that's in the database. So the more segments we have, the bigger the database. So we have to make a determination as to when these call segments start and end. So that's the important part of Geo. Within those call segments, the call will either be successful, it will be blocked, it will successfully terminate, or it will drop. We look at the layer 3 messages and read that cause code. There'll be a vendor cause code, there's a specific hierarchy of the cause codes that we take. And then the final cause code we get for that call is how we classify that call. Right. So back to the PM counters. We don't have access to PM counters. So it follows that we're not measuring those counters in the same domain, right? We're measuring them in a completely different domain. What you can be sure of, and when the system comes across to you and it gets accepted, these things are checked, but our call models are generally consistent, is that RRC attempts, that's relatively straightforward, right? So when a call starts, we should see that the RRC attempt was successful. That's entirely logical. So what you would expect is that our RRC attempt counters are very close. I can only say very close because, like I say, we're not measuring the same thing, but they will be very, very close to your PM counters. The difference comes when we get to drops and blocks. Okay? Sometimes, for example, you can see drops and blocks that exceed 100%, which doesn't seem logical. But what happens is that when a call initiates, certainly in UMTS, any other call, any other leg that fails is attached to the original call. So any call that's handed in doesn't get counted into the connection statistics on that particular serving cell. So there can be some displacement in that in drops and blocks. But you can be assured that we measure and count the specific reasons for that call goes to end. So if there is a difference, that's the reason why the difference is there. Doesn't mean that you're not seeing what's real. You are. I think one other aspect of this is, especially in Huawei, this seems to crop up. For some reason, Huawei having the messages such as, and the 3GPP message, failure in the radio interface. Okay? So in an area of interference, we might see, especially on packet data connections, they're not obvious to the user. Right? Any packet data failure, connection drop or whatever, is not obvious to the user at all. If it's a call, it's straightforward. If the call drops, you lose the connection. But if you're surfing the internet, you don't really see this stuff. And what you could see is things like failure in the radio interface, failure due to network optimization. And we have to classify these things. So if I said to you, is failure in the radio interface a drop? What's your logical feeling? Yeah, of course it's a drop. The radio interface failed. Is that obvious to the user? No. And that's why sometimes you'll see Geo count more drops and blocks than the PM counters will. But when you drill down into it, it will always be a 3GPP course code. If you find something in there that you do not believe is a drop or a block, okay, that we count as a drop or a block, then you need to flag that to us. I've certainly had this issue with another customer I'm doing a handover to now, and he doesn't like the number of network optimization counts because it's skewing his drops compared to the OSS counters. And they have a very, very steadfast mentality of they must match. Well, I can't guarantee they're going to match because I've just explained to you they're in two completely different domains. Okay? But what I can show to you is that we're making the right decision on the basis of the call flow that we receive. Okay? So everything that's counted as a drop there is how your UE is reacting to the network. That much I can guarantee you. Unless there's a course code in there, like I say, that you don't believe is a drop, if you don't believe is a block, if you come back to us, we can reevaluate that. But this has been running for a number of years now. So we're pretty happy with the way this is, and we're pretty happy that in the way we construct the call segments, that we've got a reasonable approximation to your PM counters. What does this mean to you as optimizers? What does this mean to you as people who are using the system? What it means is that you don't need to go to your PM counters once you're satisfied, of course. So once the system is accepted and we've gone through all the test conditions, you can be happy that if Geo tells you that the drop count is high on that cell, that the drop count is high on that cell. That's what you guarantee. Okay. So when you start trying to match two different systems that count in two different domains, then you're never going to get 100% match. But we will be pretty close. So I think that was a useful point. Any questions on call segments? And when we dig into the subscriber connection counts, we'll do that in the morning, you'll see the segment flow and how a segment starts at 0 with the call, and then there's a lot of handovers. So the next segment might actually be 4, because what Geo has merged segment 1, 2, 3. So the next might merge into 4. So you don't always get 1 to 100, but you do get them increasing order, unless there's a handover coming in, and that handover is not counted against the service cell, which is why you might see some counters sometimes appearing to count more than 100%. Well, that was a very long-winded way of telling you how counters and KPIs work, but it is an important thing to do. Okay. Now, what we're looking at here is the cell KPIs. So from this, for example, let's have a look at the RRC failures. So there's the attempts, there's the failures. It's logically then that attempts and failures lead to blocks, doesn't it? So if I go to RRC failures, so highest to lowest, okay. So in this particular area, we don't have any RRC failures, attempts, CS drops. We got the rates down here, right? So we can look at the various releases, the drops, and drop ratios here. Okay, so we could have a look at the CS drop ratio. Drops. All right. Okay. So there's your PS drops. So you see normal releases, PS drops, and PS drop rate here. So you can evaluate your drop rates. So another way of getting to the cell that you want to look at. Again, if I look at CS drops here, CS drops is pretty good within this area. Well, I don't know how to look at the whole RNC. Remember that I put the geographic area filter in there, right? So I'm going to clear that geographic filter, and I'm going to press apply again, and then rerun this analysis. Off it goes. So looking at a slightly wider area is going to give us a little bit of better information here. Okay, so you're here. The CS drops, not a lot. PS drops, few more. Like I say, they're the ones that happen silently in the background. So you can get to the ratios here, and you can look at. There's a lot of information here. Look, connection duration, number of subscribers affected. You can even look at throughput. Throughput is contained within the call trace data that we get. Depends on the vendor how we actually get it. I think in Nokia we have to make a calculation. We get some values and have to produce a calculation. With Huawei, we get a separate file that tells us within that connection period what the throughput duration was. So that's how we work with that. So with tables, also, here again, we're looking at cells, and we can look at the radio information here. Okay, so we can start to look at cells that perhaps. That cell there, for example, the ECNO average is a little bit low, so we could sort on that. Lots of other information we can glean from this. Look, IRAP failures again, etc. When you're looking at a table with lots of information, one of the other things we can do is right-click the top of that, and we can choose columns. And that way, we can reduce the visible set of columns to ones that we're interested in, and ignore the columns that, for the purpose of our investigation, we're not interested. Okay, so I can clear all, pull in label, RRC attempts, RRC failures, failure ratio. Okay, run that. There we go. So that reduces the size of the table. We can also, at this point, logically from here, we can save that table to CSV if we want to export it using anything else. We can save it to Excel. Now, bear in mind that the chances are the application server that you're working on won't have Excel installed. So the chances are you're saving Excel to use that somewhere else. Okay. Also in here, we can enable filtering. So we could say, if we needed to, find me a specific cell label. Okay. So you get the usual search commands in there. We've got the functions. We can edit that. We don't. That's grayed out. That's show find bar. We can get rid of that. Okay, so that can be floating in the background. We hide that, and that's basically manipulating tables. Okay, so all that information is exportable. Any questions on tabular KPIs in Geo? Did that explanation make sense to anyone? Anyone not understand or comprehend the explanation about drops, blocks, and connections? Yeah? Okay.
Nếu phần này anh chị nào có câu hỏi thì cứ chủ động hỏi, trao đổi. nhảy liên quan đến hệ thống anh qua hệ thống đủ.
Thì anh đang set up chắc khoảng 1-2 hôm nữa là có.
Ôi, đừng nó bay là xong.
Mai thì chạy
Không ạ. Bay thì vậy thì thuyết này thì chơi nó học qua tuần sau. Bay xong học lý thuyết.
Cái đầu vào nó trục chặt chưa lốt đầu vào.
cái con server đó là ở đâu? Đây là cái kia. Cái hệ thống đấy cường.
Dạ.
Cái hệ thống đấy là chặt thứ người
Lốt dữ liệu đầu vào của mình là nó cao thì nào không đúng nào chưa lốt được mới được.
cái hệ thống dữ liệu nào mới rồi. Nó cũng như nào đâu. Có cái em mà tu là được.
Chỉ người ta cũng được. Cái này nó thấy rất là có cái giao diện với dừng tác này lại thôi thì nó sắp giao diện em tự thực cũng ngay bây giờ thành thì mới không biết mới hỏi không này.
Okay. There's a couple of other things we can do in Geo2. This is applicable where perhaps you've got a network that's growing and you have a number of site deployments. You can look at optimization. Okay, so there's a couple of things you can do here. So scrambling code optimization. That's relatively straightforward analysis where you can optimize the way that scrambling codes are distributed in your network. There's also an interesting analysis called cross-feeder. Okay, now that's going to process. Now, interestingly, it's probably going to take a while. Actually, I probably should have restricted that. Oh no, it's quite quick. So, because we have a site database installed, what we can do is look at the segments that are arriving on that site, and we start to make some calculations in this. And I think the book explains it better than I can. But what it says here is that it's looking at the ideal neighbor list for cells and comparing them with the topology of the network. What it's looking at, if you look to page 222, okay, this is the cross-feeder calculation. What we're saying here is when it detects a source cell, server cell and source, then what it will do is it will come up with some angular differences. And it tries to do a match on this as to whether this is in a reasonable place or not. So what we're looking at, so see here, if we look at, okay, so if we look at the matches here, okay, so this is on a very limited data set. So I would say run it on a larger data set and this restrict it to a geographical area under investigation. But what we're seeing here is that any potential match or misalignment is shown here. It says here, for example, here we go, full match. The cells recorded as of it is within approximately 60 calculated as. So then we're saying, yeah, that's okay, that's not a problem. The partial match, the recorded is not close, but another cell's reported as is closer. However, there isn't a reciprocal relationship between the cells, so we're not going to rule it in. So potentially, if you've got a growing network and you've added these cells into Geo, by running this cross-feeder analysis, you can then identify any maintenance errors that have gone in. I don't know what you guys think, but sometimes it happens. People put the wrong feeders into the wrong port. Okay, so if you've got a rapidly growing network on both LTE and UMTS, this as part of your optimization tool can be a valuable function because there's nothing that messes a network up quite like the feeders being in the wrong place. Logically. In this instance, do we have any misalignments? I've been surprised, but let me just check. Okay, so there is slight misalignment here, but looking at the angular difference. Okay, so the assessment is SWOT. Now, this may be a mature network. It may be due to limited number of samples. You saw quite clearly when we were looking at best cells that the pepperpot analysis suggests that we didn't have a complete data set. So it could well be that this instance that is that those sorts could be ignored. But chances are, if you're running something with continuous data. So if you have 24-hour data periods and that by maybe even 3 days, but over a smaller geographical area, then statistically you're going to get a much better match here. And you're going to have a very high level of confidence that when you send somebody out, one of your maintenance guys out to do the check, then you'll have a reasonably high confidence that is good. But remember, it's only about statistics, so it relies on the data in. What does it also rely on? And it's something I talked about earlier. It's the completeness of that network topology. And it's the reason why we update that network topology daily. So everything you see in here, connection drops, points, raster analysis, if we're missing cells in there, then your data is not going to be 100%. Okay? So you can cope with it. RF is pretty good. You can cope with the odd missing cell because you're doing the statistical analysis in that area over a period of time. Back in the olden days, when I first started doing this kind of work with cold trace, because of the amount of data involved, we used to sample it. So we wouldn't sample it. We wouldn't take 100% of the data. We'd be down at 30%. And what we found was about 30% statistically, that sample data was adequate to give us a good RF picture. So you don't, for an RF picture, you don't necessarily need all the data all the time, but we do it intrinsically because that drives the other analysis that are available. I don't know what your network is, how big it's growing, how fast it's growing. Are you doing a vendor swap? Any of these things that impact where you might have maintenance activities that could lead to mistakes, so it's worth bearing in mind. Okay. Any questions or anything you'd like to look at in the kind of RF and raster analysis before we move on? Yeah? Any thoughts? It's very nice Belgium, by the way. Good beer. Very nice beer. Okay, so if there are no questions on RF analysis, then we'll move on. And we'll move on to subscriber analysis, which is next. So let me remove that. Let me see what my schedule is. Oh, this is voice call analysis. So, okay, I don't have this on the slide, which would be quite useful. So you can look, if you look at 3.1 in your book, yeah, 3.1 in your book would be good. Okay, so we're going to look at the voice call segments here, and right on cue, 3.2, we've already covered that. So if you look at 3.2, it explains the concept of call segments at a high level. And there's a number of changes there that I didn't cover. If you look at 3.2, a service change will introduce a new segment, voice or data. Measurement report that has rich enough information to geolocate the segment. And every 15 minutes, and that's applicable on the vendor side, because when the vendor generates this data, apart from Nokia, which I said earlier, streams the data, Huawei and Ericsson do not. They give us files. So if they give me a 15-minute file, what I have to do at the next 15-minute file is generate a new segment from that. And I try and match the call up. I say it's the system. We try and match the call up so that we can increment the segments where possible. And where we can't, then it'll be a segment 0. The explanation for segments is there. I've already covered it. So we talked about the call table analysis here and the KPIs. We kind of covered that already. So blocks and drops. So we talk here about the hierarchy of blocks and drops. When I was talking about the course codes earlier, if we look at 331, let me just run the analysis again, call table analysis.
In the book, if you go to any page number, you can tell other people can follow.
Yeah. So it's page 3.4, section 3, page 4. Okay, let me just I'll just clean up my desktop. Okay. Okay, I'm just going to run this call table analysis again on my specific area. There we go, got that. Okay. So as we discussed earlier, and we viewed it, we can look at the drop rate. And here it actually explains in section 3311 on page 3.4, it explains about the drop rate potentially being more than 100%, which I covered earlier. Okay, we can look at the weighted drops in here. Weighted PS drops. CS weighted. CS drops. There we go, weighted. So that's going to give me cells that have high subscriber count and high drop counts. Okay, so that's the way you can get to the data being rationalized or normalized, if you like, to give you a better view of the cells that you need to, or areas you need to get to most. So if I go to device and subscriber, okay, let me have a look at the subscriber here. So we can look at various performance summaries. Again, we have to be careful when we're running these analysis about size. So we can look at subscribers here. So if you can see here, but while I just roll that tooltip over, there's the columns. You can see here it says subscriber. Okay. So if I run this analysis now, thankfully I only have one RNC in the system, and it's very limited data. If that's your network, and your network is very busy, that analysis is going to be massive, right? And you're going to be restricted in the number of rows that can return, and you're probably going to be restricted in terms of time. You could run it over 3 days if you wanted to, or for a complete day. It's probably not worthwhile. You're probably more interested in looking into an area. In this case, I'm actually going to run it because I think it should be reasonably quick. Okay. Time will tell me if it is or it isn't. Okay, let's look at that. Just playing catch up. Okay. All right. So this is going to ask me for a filter. So it is actually going to reduce the filter set that I've got. So let me add a filter here and let me see what we've got. So this is interesting. If you've got a, if you manage a set of VIPs in your network, what we can do at this moment is we can, or your administrator can do this and keep it updated. Is you can add specific lists into the background. So that database I was talking to earlier that contains your network, it's also got subtables for you to add neighbor VIP lists in, or lists of your own. You can do that as well if you're interested in specific cells, or even Bs or RNCs, or not Bs. So you can add other lists. In this case, it's a subscriber analysis. So we can either pick a particular subscriber or group of subscribers, or we can look at our VIPs. So if you had a call with VIPs, for example, very often when this system arrives in a network such as yours, I guess you've had a similar system before, so maybe this is not going to be the case. But what normally happens is all the VIPs, all the people upstairs, right, with nice cars and everything, the first thing they want to do is they want to see how their call is being handled. And they're really interested in seeing where I was on Sunday And why did my call drop when I was leaving home this morning? This is very typical coming from your VIP. So you can do the VIP search here by end. So you can maintain a VIP list. And then you can select your VIP or group of VIPs from that list. So say you have, I don't know, mobile phone senior management in Hanoi, mobile phone senior management somewhere else. You might want to create different lists so that your senior management are being looked after. When they pick the phone up and say, I was at the restaurant on Sunday night, why do you have a call from? Okay? Then you can jump straight into your list and analyze these VIPs. So I'm just going to pick a random subscriber here. I have no idea which subscriber it is, but I'll pick one. I suspect we don't have a VIP list. So right now this is going to go off, and this is giving me the particular subscribers, the IMSIs in this case. So what I'm going to add is, let me add a couple. I don't know how busy these IMSIs are, but I'm going to add them anyway. I'm going to apply and run it. Now this is going to come. That's typical, isn't it? No data. So the IMSIs aren't giving me any data in that context. What I'll do then, I'll just jump to something. So I'm going to look at something to give me data that's real, okay? So I'm going to look at the top end calling subscribers. So this is another way of getting, it helps me anyway, to get to the bottom of what I'm trying to do, okay? So you can see, we already knew that this data set was limited. Look, but here's my busiest subscriber, okay? So I'm going to take that, copy that selected cell here. I'm going to go back into my subscriber analysis. I'm going to get to the cell on that, the filter. So I'll open the filter in the corner. I'm going to clear that. I'm going to add this subscriber here. So I add that filter in the bottom. No need to search for him because I already know he's in the network. So I'll pop that filter in there. Control V. Important point of this, remember to click the add button, because if you don't, you'll run the analysis without any filter. And I do that all the time. I put it in there and I hit OK. I need to hit that button first, and then I collect OK, and then I apply and run. Okay. So here we go. So not only is he not very busy, you can see here that there is not a great deal of records to that subscriber. So you can see actually that subscriber was served perfectly. Ideally, I need to try and find some with failures. So let me try the next one down. I'll tell you what I'll do. There is another way of doing this. I will go to, this is probably the one I should have run first off, but again, this is all into your subscriber analysis. So find me my worst subscribers drops, okay? So off it goes, comes back, and here he is. Not many drops, that's true. Copy that selected cell, look into my subscriber, update the filter. Edit. And this is another way of getting rid of that. So you can click that, remove it, click that, or let's go up here. Let's go search him. Let's say we're searching for a subscriber. So I'll end it here. So it'll go off to the system, and it should find that subscriber. And why it hasn't, I don't know. All right. So I'm expecting that subscriber should have showed up. So let's see if it's in here. You should be. All right, so here we are. Here's the specific failure reasons for this or performance for this particular subscriber. Okay, like I say, limited data set here, so you would expect in your network that you're going to find subscribers with particularly degraded performance. Okay, so there he is. There's his CS drops. Here's his drop rate, which is pretty poor. I know in this instance he's not had a lot of calls. Normal releases too. So he's had more drops than he has calls, right? You can see that clearly. So if that was a subscriber that had been run over a 24-hour period, you'd be very concerned as to why that particular individual was experiencing drops. Let's have a look here. What else can we do? Subscriber counts. Okay, there's other things we can do here. We can look at the back into the RF folder. Again, we can look at areas Let me just close these down. So we came back here, we looked at the weighted CS drops to dig into this voice call kind of analysis. We can look at drop rate block, weighted blocks, and we've got some more analysis somewhere. Unique subscriber count. Let me just dig into that one. Oh, there it is. So under subscriber. Okay, there we go. So again, we've got another map count that we can look at here. And again, this will show us where we've got the most unique subscribers. And I think from your point of view, when you first start using this system, one of the things you're going to say is, how good's the geolocation? How do I know it's accurate? Okay, well, you need to think about where you are in the network. And you know, probably by now, you've been working on your own network for a long time. You know that whichever train station is busy, all these sort of things. So if you're running unique subscriber counts, and let me just remove that for a second, just to show what's underneath this. Okay. Well, why am I surprised once more? Because here is my unique subscribers. So I'm looking at users with calls. We can look at this here. You see, I've got the red in the middle. If I deselect that, my knowledge of French is good enough to tell me that that's the train station. Okay, so it's logical. So here we are, Boulevard de Gare. Gare is station in French, and actually you can see the railway lines underneath there. So users with calls. There you go. So straight away you can see, even with that limited data set, we can identify that that particular user has a lot of subscribers. At that point, we can look into this. And again, this is a high-level view. Before you drill down and do the investigation, you can just look at your network and see what you've got here. Let me look at this users with CS drops. Okay, CS drop rate is quite good here. Took unique users. Again, you can see here, if I use the raster analysis, that the station is quite busy. Bearing in mind, we haven't got a lot of data. Okay. So I can look at the other PS drops. Yeah, okay. So these are the 50-meter squares where people are experiencing PS drops. And like I said earlier, with the number of data connections that you're setting up, that's more likely to be visible to you than it is to a user. But you can clearly see here for circuit switch, we didn't have many. But there's a voice. So you can see here, this is the number of people using the voice service in this region. And what we can do is when we move on to the tabular analysis and drill down into that, we can use filter by service to home in onto the failures or the subscribers that we're trying to target with our optimization. Okay. Excuse me. Blocks, calls. We look at calls now. So I moved on to section 3.6. Close this down. I'll look at calls, and we can look at the call count table. It's all very logical in here. Let me just close this one down. Okay, call count, which is a table. So again, very high level view of what's going on in my RNC. This will refer data. Another way of looking at the network health, if you like. It should produce me some results very shortly. There we go. And that details the service we're seeing and durations and the number of blocks. You can see here that the SRV, there is a high number of blocks. Exactly what the reasoning behind that, I don't know. But yeah, you can filter that by service. Or PS blocks, CS blocks. I'll go to CS. I don't think there's many there, but let's have a look. Yeah, I don't think there is. If I filter this, another way of looking at it, we can look at CS blocks. Yeah, so there you go. Virtually no CS blocks. If I look at what else? CS drops. Okay. Sort largest to smallest, and you can see that my CS drops are specifically happening on these particular services. Now, what action you might take on those is really down to the investigation that you do. If you're getting high counts in there, then you can filter the call segments, which we'll talk about later. You can filter the call segments by that service and start to evaluate the layer 3 drill down for those particular services. So we looked, I think, at failure reasons. Oh, no, let's have a look at failure reasons next. Let's close this one down. So this is on 3.7. So this is an interesting one that's really applicable to UMTS. There are other reasons we do this, other ways to do this in LTE that I'll cover maybe tomorrow. So we can look at probably this one, the failure reasons here by, well, it's kind of logical, really. You've got the combined failure reasons. So if I just roll over the top of that, so that's going to give you the completion and the network view. Let me just run that for a second. Let's just see what we've got here. All right. So here we go. Here is, this is a Huawei network, by the way. So I didn't actually look at this prior to doing this, but what was I saying earlier about radio connection with the UE? Remember that? So you can see here that that's a relatively high count. Failure in the radio interface procedure, that was another one that I picked up as well, right? And that's from a completely different network. So these are the these are in RANAP. There's a timer relocation expiry here, so you can see that might a network viewer drop. So your subscribers, when they're using the network by service, will experience these. Let me just filter this by. So if I just filter this here, if I look at service group, filter here. So let's look at voice, just see what we've got. I don't think we've got a lot here, but okay. So I can then start to look at these reasons here. Okay. Now, unknown, that means that Geo wasn't able to obtain a cause code for that segment ending. So it could be that a segment was truncated for some reason, or some other reason. I would have to look into that and try and find the segments to see why no record was given of that drop. But there you go. There's another one. Failure in the radio interface procedure. 7 of those, and GTP resources unavailable. So this is where you can start digging into these calls and finding out why the failures are happening in your network, and what you might want to do to talk about with your other optimizers as to why that might be the case. Look at the call segments, look at the radio environment, congestion on the cell. There could be a whole host of things, right? That's really down for you to look at. That's the combined failure reasons. We can also break those failure reasons by cell, so it's kind of logical that we could start to look and see which cells are now giving us the failure reasons that we identified there. So as you can see, there's a rich set of data here in Geo, and there are many different ways you can slice it. Okay, so the important thing is that when you come to access this, is to look at your book, look at the analysis, see which analysis does it for you. What are you trying to find out from the network? Which is your route to your success? And you can see that there are many ways of doing it. Okay, some might say too many ways of doing it, but there are specific ways, and we will try and look at some specific use cases that give us actionable points to be able to drill down very quickly. So we'll look at things such as road analysis. You're all well aware, of course, that Drivetest is out there, and when somebody drive tests, they're picking up the measurements or the GPS and the measurements on that road only. You're familiar, I believe, with the geolocation solution that may or may not use call trace. I'm not sure, but at that point, then if a guy is sat indoors, that he's giving you a different view of the network, and that's what we're doing here. When we receive that call segment, when we parse it, we can make a determination whether or not that call segment statistically was indoor or outdoor, we can filter on that in Geo. So you can just set these filters anyway. Show me the indoor group. And I'll talk about how we calculate that when I get to LTE, because that's important. Because we can also look at subscriber mobility, stationary, pedestrian, mobile, high speed, all these things we can look at. So failure reasons by cell. Vendor specific failure reasons. This is an interesting one. Now, obviously, we're going to have Huawei here. Sadly, there isn't any. Okay. And you can see in this particular instance, did I filter this by time period? So the vendor completion codes, these are the ones that we're picking up from the Huawei itself, and they'll be recorded. The Huawei guys know what these mean. So this SRB setup, the RRC connection timeout. I'm not an experienced Huawei Node B or RRC engineer, so you would need to talk to those guys. And again, there's a high number of unknown counts. So I'd be investigating this here. I'd be saying, what's going on with this call trace? Why have I got unknowns? That's what I would be looking at right now. We covered there. Let me have a look, see if we've got a multi-layer failure reasons table. Okay. Failure reasons, we covered that. So we're going to 3A. And I guess this is the bit that people want to see, because it's got it's actual subscribers and it's actual locations, right? So that's the bit that starts to get interesting. The other bit, the RF is good, but subscriber is always important for people to see. Now, as I step to one side and I move on to the issue of subscriber. Okay, so when a call trace comes in, so is there any specific issue? You okay?
You're asking for which page number you are going to page number in the...
Okay, right. So right now I'm looking at section 3.6, plotting individual calls. Are you looking at 1 or 2? Oh yeah, good, that's it. Are you looking at the part 1? Yeah, that's fine. That's good. Yeah. Right. So I'm on this, effectively this page. Yeah. So what I've just done is I've dragged onto here. I wanted to talk about locations and subscriber very quickly. So what I've done here is I've pulled the drop locations out. And again, I've just pulled this out because I know I have a massive data set. That's giving me drop locations for all my subscribers. Okay? If I do this naturally on your network, that is going to be absolutely meaningless. Because what you really need to look at is you need to look at the raster map that we looked at earlier. That gives you a better view of the distribution of your drops. Okay, so that's not the way to do it. But I'm doing this for a reason, just to show you that we are plotting an individual call. And like I said earlier, this is no longer restricted to a 50-meter bin. This is an XY coordinate converted to a lat long that we plot on the map. Now, in UMTS, you guys probably know this already, but I'm going to reiterate it. The subscriber identity arrives in the call trace files. Okay? So when you go out and your geo system comes down to you and you investigate UMTS, there is no issue with you searching for particular subscribers. When we get to LTE, we'll see that that's not the case. LTE derives its subscriber identity from the MME. Okay? So it means that we have a separate set of data that we need to get from the MME to pull back to Geo. So UMTS, you're absolutely fine, and you can run your subscriber identity and you can subscriber analysis fully across the full set of RNCs that your system will cover. Okay? So I'll leave that there, but just be important to note that UMTS is not the same as LTE. UMTS you can carry on, no problem. Okay, I'll discuss LTE tomorrow. There's no point in being sidetracked, but that's the issue of enrichment. So what I've done here is I've looked at the drop locations holistically for a whole area. And I guess what I should do, so let me go back into my subscriber folder again. And what I'll do is here, I'll pull out my worst end subscribers drops, okay? Okay. So there's my worst end subscribers drops. I'm going to take this subscriber image here at the top, okay? I'll copy this. And then I'm going to come back to this drop locations analysis. And I'm going to update this filter here in subscriber. Okay. Again, I'll put him in here. Into the subscriber. Okay. Apply and run. Now, there we go. There's my subscriber drops. Now, if I look at the legend here, so I'm going to get some color codes from these little blobs on the map that tells me where he was, and they'll tell me which particular drops he was having issues with. So you can see that orange if we don't know what the hell it was. Green is signaling, so clearly he's having drops in the signaling procedure. Red if it's circuit switched, blue packet switched, and brown is unknown, or maroon is unknown. So undefined versus unknown, that's an interesting one. So I'll find out what the answer of that is, and I'll tell you tomorrow because I can't remember off the top of my head. Okay, so there he is. He's having signaling drops. So let's use this tool here, and let's zoom into this particular area. Okay, once again, have no idea what this area is, but this is where he's having his signaling drops. He's got quite large colors here. Let me run one other thing just to show a. Okay, let me look at his locations full stop. So I can run now. If I go to points, I can actually run locations for this guy. Okay, so he's the location that's going to come. I'm going to kill that analysis. If I right click it, I can cancel the analysis. The other way is to use the nuclear button at the top, okay, to press cancel. I'm going to enter this particular subscriber in here. You notice also that you can enter other ways of identifying the subscriber there, right? IMEI. I'm going to apply and run because I'm looking at this guy's particular locations. Okay, so there is locations, and actually they align nicely with his drops. This guy is not having a very good experience, is he? If I look at his locations, they're almost perfectly aligned with his drops. Okay. Yeah, more or less. He's in some locations where he didn't have a drop. What we can do here is if we have multiple subscribers, one of the things we can do is to look at the properties. And in this case, we could change the symbol. Okay. So if I wanted his locations, then let's have the locations as, let's have them as a cross. Okay. Close that. So you can see now I can identify his locations as opposed to his drops. So we can now differentiate between those colored blobs on the map. Okay. When you've got multiple subscribers, you'll notice in there you can also change the color. Yeah. So if I click on that color field there, I now get the option to change that. Okay. And again, that's how you can differentiate visually in the map. So that's his locations. One other thing I need to talk to you about locations while we're here is I'm going to show you something else. And I don't know if I'm going to get different results, but it's important for me to show it to you, I think. Okay. If I go into VIP locations, Now we have no VIP set up on the system naturally, but I am going to add this particular subscriber as a VIP right now, just in this particular list. Okay. Did you see what happened there when I did that? Yeah. So I've run locations for this subscriber before, and there's his location. Now I'm going to tick the VIP locations. Okay. Look, he's appeared some more times. Why has he appeared some more times? Well, when Geo takes the call trace, it parses the data, and then it attempts to make a geolocation upon that subscriber. It will look at the elements in the measurement report, the data available in that data set, and it's trying its best to come up with a geolocation for that device. Once it's done that, it produces what's called a confidence level. And if that subscriber location, if all the elements that it uses to make that determination are not in place, it reduces the confidence level. Okay? It's not saying the higher the confidence level doesn't mean say the more accurate it is. It's just that the system statistically thinks there is a better chance of that location being where it is. If the confidence level drops, if it drops below a specific number, what happens is Geo says, I'm not happy about this. And because I'm going to use that location for RF analysis, I'm not going to store that location in the database. Because if it did, and it wasn't really happy with the conditions that made it geolocate, it would be providing poor quality data into your RF KPIs. Right? So those rastered bins, they're all geolocations with a confidence level above a certain amount. Now, if you run the VIP analysis, the VIP analysis ignores the confidence factor. So those confidence factors, so that geolocation point is still in the database, but it's only being counted as a geolocation point that is not contributing to the other KPIs, the raster KPIs, the RF KPIs. Okay. By running VIP, what I'm doing, I'm saying ignore the confidence filter, give me his locations. So Geo at that point will return all the locations for that device, even those with a low confidence factor. And we'll see that when we drill down into it. Okay? So that's Geo protecting your data from poor information. That's how we do it. It also means that if you've got a subscriber list, a VIP list, those people upstairs that I was talking about earlier, what happens is when you enter that subscriber list, when that call segment comes in and it's identified as that VIP, what actually happens is pushed into a VIP area whereby all that data is stored. So it works slightly differently for VIPs. VIPs, so I've counted this as VIP now, but I haven't loaded it as a VIP list. The VIP filter I've done is post-processing filter. I said, here's my VIP, get me the data. When I upload a VIP list, it's pre-processing, we're at the processing point. So as it parses that data, as opposed to this filter, which is acting on stored data, if I upload a VIP list, when the parser sees it, it says, hi, here's a VIP. I'm going to store it as a VIP. And what's more, I'm going to send this to the web. And again, we'll talk about that. There's a specific web server. Okay, I'm going to send it to the web server right now. I'm going to send it as a drop or a block or whatever, and it's going to the web server now. So your VIP information will end up in the database, but very, very quickly, within a few minutes of receiving the call, that VIP information is uploaded into your web server. Just as a point, what I've seen in the past is that people in the NOC, the Network Operations Center, say there's somebody out there, do you have people evaluating your network, right? And they drive around and they give you a network score, and they say, mobile phone is the best network in Vietnam, or mobile phone is the second best network in Vietnam, or whatever. Hopefully you're the best, right? But that's where you want to be. So you get these people doing network scores. What I've seen before, and this is something to bear in mind as you go forward, is people in the NOC having the web output of Geo on a big map in front of them. Because these guys are not the IMSIs, the people who are out there doing the network evaluation. And this network is being updated in the NOC on the web server very, very rapidly. I say almost real time, there's always a delay of producing these files that coming through. So I can't guarantee how quick that's going to be. But certainly these guys in the dock, this is in the UK, Vodafone, I was looking after the Vodafone account. They were sat in the NOC and they were getting the geolocation events and the drops and blocks from the people who are out there evaluating the network. So they were rapidly trying to fix their network on top of a network that was being worked by the evaluators, if you like, the network scores. So that worked for them. That's just a thought for you in the future. Okay, so that's the difference between VIP locations and locations. What time is it now? It's now 4:15. I'd like to leave the drill down to tomorrow because once we get into drilling down into calls, we will go down, as we say, we'll go down a rabbit hole, right? And we'll be here till about 8 o'clock tonight. Okay. So I guess you guys, like me, don't want to be here till 8 o'clock tonight. Okay. So at that point, does anybody have any questions about what we've done today? We're about 15 minutes short of our finish time. Any questions? Okay, the people online, I don't know if you have any questions. I haven't seen the call. Forgive me. Let me have a look at the... Okay. So what I'm going to do here now in the room is, like I did earlier, okay, we've got 15 minutes to go. There doesn't appear to be any questions. What I'd like to do is again offer my system to anybody in the room who would like to come along and try this, okay? So that's not going to be possible for you guys remotely. So I would say thank you for your contribution today. Unless you have any questions, you can leave. Okay. So in the room, if you have any questions, by all means, raise them now, or you can, I'll be standing here, come talk to me. I know there's only one computer, so whoever wants to be first to have a go, run a few analysis, try a couple of things. Anybody? Volunteer? Volunteer? Any volunteers? I know you've all been desperate to get on the system, so somebody somewhere must want to have a play with this. Anyone? Anybody on this table like to? I am going to pick somebody in a minute. So.
Nhưng mà không biết được hết mà.
Trên màn trình độ. He asking about the deep monitoring pressure.
Ah, okay.
And that how accuracy can show you the
Yeah, so the VIP is geolocated the same as everything else, but as I indicated earlier, because it is a VIP, we will allow those locations to be shown, even if we're not 100% sure.
how accuracy for the location.
Right, so location accuracy is a big subject. I'll come on to that. Can I take that in a separate session? But it depends on the richness of the information. That's the main point. But what we need to do is to know when the bit has a block or a drop. So that's when we publish the data, even if we're not that happy or we're not that confident about the location. Remember, confidence is not about location accuracy. It's simply the confidence that it's close as it can be. But because it's a VIP, we appreciate that the drops and blocks in the bit need to be known. So it could be that VIP has very little information in there, but we'll try and give it an approximation. Geolocation depends on a number of factors. In fact, there are a number of geolocation types. So if I look at, let's look at this. It's a really good question, actually. And I think this is worth half an hour on its own. So if I look at locations, I might be able to, sorry, I know I talk very quickly. I might be able to look at it on this map. If I look at this filter here. So what I'm going to do here is I've filtered it by the VIP in this instance. And if I look at how that VIP is geolocated or the types available, okay? So when it comes to geo-parsing an event and looking at geolocation, these are typically, these are the range of options available to it. Some of these are applicable, excuse me, to LTE. So anything here that says roads on it, that's LTE. We'll talk about LTE geolocation separately. Anything with GPS, that's likely to be an MDT initiated measurement, maybe, that will have GPS in it. So these are all the different types of geolocation that we use, right? So depending on the information available, so anything here that says multi-swarm, that's LTE, because I talked about it earlier. So here we've got, for example, a single neighbor co-located. So that means in the information, what we had is a subscriber measurement report, excuse me, that had a single neighbor in it, as well as the serving cell. And that single neighbor was co-located on the same site as the serving cell, okay? So that's one way we geolocated it. So we could have single neighbor, but not co-located. So all these would give different weight into the geolocation and improve the geolocation process. So when we have the most information, we've got lots in the active set, we've got all sorts of other information with LTE, timing advance is applicable. How often we get measurement reports, that's how the geolocation will be improved. I'll get the white paper which shows the specific reasoning behind geolocation. I think that's an important thing to use. So what I'll do, if you excuse me, I'll present a separate session tomorrow on geolocation and what we expect. Yeah, is that okay? Yeah, because geolocation, we're talking about an individual here, an individual VIP. That's what we call single call geolocation. So it's dealing with one call, and that call is loaded into the database. When we aggregate something over a period of time, that's multi-call geolocation. And what you would find is statistically the accuracy of multi-call geolocation is better than single call geolocation. That's not necessarily always the case. You might have a single call geolocator that's got all the information, the best information it could possibly have, in which case it's good. The less information it has, then the more likely it is to be slightly off. And I'll talk about that and centroids. I'll talk about centroids and how we can calculate geolocation. But it is worth a topic on its own, if that's okay. Yeah. Okay, the offer still stands. Come and drive Geo, have a play with it, have a look at subscribers, have a look at some RF KPIs. I know if you had access to your own system, you'd all be doing it right now. So there you go. I've even warmed the seat up for you. Okay.
Có hệ thống test ở đây thì anh chị nào muốn để lên play thử trên hệ thống này đặt ra câu hỏi yêu cầu gì?
Okay, just in case you're shy, I'm just going to the loo if that's okay, and I'll let you have a discussion.
Cô đang ngồi ở bài đó.
Được rồi. Nghe nói thì nó hay. Nhưng mà nó không phải
Không, mấy cái này đấy.
Em nào thích
cái level 3 nên ta học đến đây thể người biết.
Vừa đi. Bây giờ cũng có thể nó phòng này nó đang là nặng khác rồi. Chính là lên này cái này nó đang là
mình bắt chước tế sau này
anh này thấy là test luôn nhập luôn cái MC của mình vào
cái này xong rồi phân biệt nó cao thì nào phần nào
em có số của anh
thì sao thì
nó có thêm MC nữa thì có MC và những có video biết là công nghệ video là công nghệ đưa ra vị trí hỗ trợ từ các báo cáo lên vị trí cao
thì có chỉ biết đến sao
tùy vào cái dữ liệu data của
đang hỏi gì vậy?
thì đây bây giờ cách nhưng mà trong một cái cách này anh biết là anh
theo nói đây hoặc cái tương đối thôi nó sẽ khoảng nó rơi khoảng 10 mét 15 mét đấy
Just a quick mention is
nhưng mà
see how I've not taken
chính xác không phải 15 mét đấy anh ạ nhưng mà bình thường
if you had access to your system. So if so the guy's going to be taking computers. This is the Geo student. There are two reasons why I wanted it. One, I knew you didn't have access to your system. Two, I certified however, Google does have a copy of this, so you will.
đúng rồi nó sẽ mỗi một điểm đi nhé nó sẽ có một cái pin code
Basically guide you through the system.
cái điểm đó chính xác khoảng tập trung hơn.
So these are typically the exercises that you could do on Geo, or if you want to look at my machine, do that.
xong rồi anh chia ra xong rồi xuống xử lý
hai là nào
vì là gia đình đến tầm tối nay đến
sẽ phải đôi hết khu vực này
thực ra thì bên anh có thể vào được nhưng mà mở ra được nhưng chưa nhìn thấy dữ liệu có dữ liệu này chưa nhìn thấy cái dữ liệu cho nên là vì là hôm vừa rồi có tuần rồi thì nó gặp một chút vấn đề trong việc thu thập dữ liệu rồi đi chiến luôn nó chung nó máy các bạn toàn trình từ này ra qua cái đối tượng này gồm con số và bên số cho khách hàng VIP thì cái đấy thì ông có matching cái mapping cái đấy phải được với answer.
Yeah, sure. Often than that, How I get to that. Okay, fine. Yeah, so what I will do tomorrow is I'll look at the worst end subscribers, and I'll take my poorest performing subscriber, and then what I'll do is I'll look at his call segments, and I'll find out the reasons for him to drop. So if I take, I'll just give you a preview. Okay? We'll have a preview. So if I take that subscriber, and if I look into his call segments with RF, okay. So we already know that this guy has had a few bad calls. So what I'm going to do now is I'm going to take the call segments I was talking about, segment 0, 1, 2, 3, or whatever, and I'm going to pull this subscriber's call segments back into Geo. Okay. And this is for a whole day, so there are going to be many segments here. So very quickly, I was just asked a question about drilling control calls. I will go into this a little bit further tomorrow. But what I've just done is I've taken my worst performing subscriber in the network, and I've talking about call segments. So what I've done is I've got all the call segments on subscriber. Bearing in mind that I've only got 30 days, how many call segments to generate that subscriber. That's why you'd have to be very careful with this analysis. You find yourself pulling in large values. Yeah. So this is my worst performing subscriber. And so we can see here that by filtering on his segments, we can look at his call starts or his call ends. Okay. So we see he's been up to segment 1360 in a continuous call. Within this, of course, we can see which geolocation type we've used. So tomorrow I'll give you an example of the geolocation types and what they mean. Some of these geolocation scenarios are better than others. Okay, simplex is not so great. So what we're going to do is we're going to calculate a location for that subscriber based on the information that we have. So simplex is not a lot of information. Again, I'll go through that properly tomorrow. But you can see here how we built this up. Some of these are better than others. Multiple soft handoffs, that's good. Multiple soft handoff previous location. Again, I'll talk about them tomorrow. But this is really how we get into the point of what a subscriber is doing. And we can look at its completion code here, which is the thing I've just been asked about, analyzing a subscriber's drop. Okay, so what I'm going to do here is I'm going to look at, well, I'm going to look at the RAN app. And I'm going to say, so these are the actual specific release codes that were within for that subscriber. So you can see here within the RAN app, we've got actual reasons that are bad, or we can look at completion code. And we can also look at the end reason, if I remember correctly. Find that one, service, completion code. Pretty sure there's an end reason in there. There's lots of it. Anyway, I'll dig into this tomorrow, and we will look at drilling into a specific subscriber and having a look at what his issues were. So there's the network view I was talking about. Occasionally we see. So you can see here that already we can see, well, the network view of this was a drop. So I'll filter that by his drops. There we go. And I can see we've got 527 drops. And then we can start drilling into the failure reasons as to why. Okay. There's our connections, and we'll drill into that. But that's something we'll do tomorrow. That's the drill down into specific subscriber experience. Okay. Okay, it's 25 to 5. It's 4:34. If there's anything else, are we? Yeah. Okay. Thank you very much for your attention today, folks. I know it's been a long day. I'll try and keep it as interesting as I possibly can. And hopefully, as we go forward, we'll get you access to the system. Like I say, whenever I have some time out here, this will be open for you. Please don't hesitate to come along and have a look and drill down, run an analysis, set a filter, just get used to using it. So throughout the day, I'll offer a specific few minutes when I have a break and you can have a play. Try and keep it a little bit more interesting for you. Thank you very much for your attention today, and I'll see you all tomorrow. Thank you. And if you think of any really tough questions overnight, yeah. Not too tough though. Thank you to those who are online. We're about to terminate the session now. Had no real takers for the demo, but that's up to people to access. I'll offer them the same access tomorrow in lieu of a real system that they can access. Hopefully you found it interesting. If you've got any comments or feedback, please let me know. I'm delivering the course in a different language, and I need to make sure that you guys are getting the best value out of this. And if there's any way I can improve my presentation, then please let me know. Thank you very much. Bye.